Hello, this is Unit 4, Module 4, Session 1. The name of this home connection is Unit 4 Review 1. It's a two-pager. Put your name and number at the top, please. As you might guess from the title, these are things that you should be familiar with after doing Unit 4. And it gives you an example of these addition problems. It wants you to use the standard algorithm to solve. How do you know you're solving the standard algorithm? Well, if you see a lot of ones being carried in an addition problem, you could probably guess they're using that standard algorithm. We're going to start on the right side of the equation and add first. 7 plus 4 is 11. Carry the 1, right? So that's our standard algorithm. If your addition gives you something that's 10 or more, you got to carry that 1. 1 plus 8 is 9. 9 plus 1 is 10. That's a 10 or greater, so I'm going to carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. Our answer is 801. Now, rather than take a lot of time in this video to do this over and over again, what I'd like you to just think of is this. This will add up to more than 1, so you're going to have to carry. And this is kind of a connection. That's not a 1 that I'm drawing. That's a connector. Okay. Also in this is going to add up to more than 1. This is going to add up to more than 1, which means that this is going to, well, with whatever you put up top, that's going to add up to more than 1. So there's going to be a lot of 1s that you're carrying in this one. Keep that in your brain as you work. Make sure you pause this video so you can work through these. Now they're going to do subtraction. So it looks like they're going to give you 3. They gave you an example. You know you're seeing standard algorithm when you start seeing these numbers get crossed out and they start adding 1s. You're borrowing 1s. Why would you borrow a 1? Well, 5 minus 8, you can't do it because there's more on the floor, so you go next door, right? And what a lot of the teachers do, and the examples in your text do, is they will cross that out and rewrite it with the borrowed number, just to make it a little bit more clear. I'm going to borrow from that 4 to make this 5 a 15. I place the 1 next to the 5. Now I can get rid of this 4 and borrow a 1 from it, which makes it a 3. Okay? So I took a 1 away from it. It's a 3. What did I do with that 1? Well, I put it next to the 5. Now I can subtract 15 minus 8, 7. And then I'm going to do 3 minus 4. Oh, man, once again, I can't do that either, so I'm going to go next door. So this 3 is we're going to borrow from this 7, turning it into a 6. The 1 that I borrow is going to go next to the 3, making it a 13. Now I can subtract 13 minus 4, which is 9. 6 minus 5, I can do that, which is 1. My answer is 197. I say this to my students, and I'll say this to you as well, if you're not my student and you're watching this video, that it is hard to borrow on a printed math sheet. These numbers are so close together. My finger is bigger than the entire problem. I find it much easier to rewrite them on another piece of paper and write them in bigger print. Okay? That's just a suggestion. It's really hard. Do you see how they, look at this. I'm going to zoom into this. Do you see that? Oh, don't think I can make this any closer. Ah! Do you see how tiny that little 1 is? It's almost impossible to write that with like a pen or a pencil and to feel like you're being really accurate. So if you get to the point where you feel like your paper is just too messy for you to know what you're doing, then keep that in mind and possibly write on some scratch paper. Number 3 wants you to complete each equation by writing a number in base 10 numerals. How do you know it's base 10? This is my base 10 these are my base 10 numerals. I've got a 1s, a 10s, a 100s, a 1000s, a 10,000s. This is my base 10 numeral. I got that by combining all of the place values. Okay? What is interesting is that sometimes you might be missing one of the values. I've got a 10,000 number, I've got a thousands number, a hundreds number. There is no tens in this one. That's why there's a 0 here. Right? But there is a 1. There's a ones place. Okay? So if I look at B, for example, I've got 1, 10, 100, 1,000, 10,000. So this is going to be 1, 2, 3, 4, 5. A 5-digit number with no zeros. Okay? And I should be able to just go 3, 2, 1, 1, 2, because this number, if I add make sure my comma is in the right place, this number is 32,112 if you were to add all that together. Now, let's skip down to D because I see something. Because I like patterns. If I look at this, I have 4 zeros, 3 zeros, 2 zeros, 1 zero, no zeros. And if I write that, that might help you. There's 4 zeros, 3 zeros, 1 zero, no zeros. Oh, that's interesting. Because up here, I had 4, 3, 2, 1, and no zeros. So that means there's something missing here, isn't there? Okay, here's ones, here's tens. Uh-oh, there are no hundreds in this expanded form. So I do have 96,000. Okay, 90 plus 6 is 96,000. I have no hundreds, but I have a 30 and a 5, 35. No hundreds, 35. 96,035. I'm actually going to do a few more of these with you because I really like I like to show you an example that has all of the zeros, the places represented, and ones that don't. This one had no tens, which is why there's a 0. This one had everything, so there's a number on every digit, in every digit. I had no hundreds, so that's a 0. Okay, I have 4 zeros, 3 zeros, 2 zeros, 1 zero, no zeros. So it looks like everything is here. Ones, tens, hundreds, thousands, 10,000s. So this I should be able to just write the first digit of every number and have the number that I need. 13855. 13855. Make sure your comma is after the thousands. 10,000 plus 3,000 is 13,855. Okay, I'm going to find one more. Okay, now I'm going to come over here, and as I look at this, I have ones, I have tens, I have hundreds. Uh-oh, I have no thousands, but I do have 10,000s. So I have a 2, then a nothing, 4, 5, 6. So this number is 20,456. They didn't give us any thousands to work with, which is why I end up with a 0 in the number. I'm going to let you do these last 4 on your own. If you need to rewatch any of that, rewind me. I'm on YouTube, right? Number 4, you're going to fill in the missing number for each equation. This is the opposite of what we just did up here. Okay? So if you notice they had this blank here, they put a 50 in there because there's a 5 in the tens place. There's an 8, there's a 5, there's a nothing, there are no hundreds. Okay? That's why they have a 0. They have a 6 and they have a 4. Okay, it all works out. So when I look at a problem like this, and I look for this missing value, I've got a 1 and a 5. What's in between the 1 and the 5? A 3. So I know I'm going to have a 3 of some sort. What's its place value? The 3. Where is it? Ones, tens, hundreds. So that has to be 300. Okay? So if you want to use that strategy, please do. Look for the missing number and then fill it in. Okay? What about this one here? 96,035. I've got a 90 and a 6,000. 90,000, 6,000. And then I've got my ones. What's missing between the 6 and the 5? Here's the 6. Ooh, where am I at? Here's the 6. Here's the 5. Now you might say to yourself, there's a 0 and a 3. But we don't write anything if there's nothing in the 0 place. That's like 0, 100. 0, 100 is nothing. So we don't worry about that. But there is a 3. I write the 3. And then I ask myself, what place value is the 3 in? This 5 ones, 3 is in the tens. 3 times 10 is 30. Okay? As you do the remaining questions, I do want you to try to use that strategy where you try to figure out what number is in between, like the 4 and the 9, 4 and the 9, and then figure out what its place value is. If you see a 0, don't let it fool you. You don't write it, but when you're looking, ones, tens, hundreds. There's nothing there, but that's still the hundreds place. Thousands. Okay, so just use your clues. On the back, we have a little bit of review using word problems. I'm going to back out so that you can read the whole thing with me. It says, use the standard algorithm. Show your work. In December, the cafeteria served this many breakfast sandwiches. During the first week in January, they served this many breakfast sandwiches. During the second week of January, they served this many breakfast sandwiches. How many more breakfast sandwiches did they serve in the first 2 weeks of January than during the whole month of December? So in December, they had 972. In January, they had 486 and 538. Oops, wow. Sorry, that 8 didn't turn out very well. So they want to know how many more did they sell in January than they did in December. Well, first we have to combine these two numbers. And you could do it a couple ways, but I'm going to stack and add. Standard algorithm is what it says to do. Stack and add. 8 plus 6 is 14, carry the 1. 1 plus 3, 4. Plus 8, 12. Carry the 1. 5 plus 1 is 6. Plus 4, 10. So in January, they served that many breakfast sandwiches. In December, they sold this many. What did the question say? How many more did they sell in January than they did in December? Now, we could do a number line. We could break these numbers apart, maybe do some work in expanded form, but it says to use the standard algorithm. So we're trying to find the difference. So I'm going to take my 1,024 and subtract 972. The first part's not too bad. 4 minus 2, 2. Yay, 2. 2 minus 7, oh no, there's more on the floor, so I go next door. Oh no, there's a 0 there. I can't borrow from a 0. And if you know this strategy, then this will be familiar. If it's not familiar, I hope this is helpful. My goal is to take a 1 from somewhere. But if there's a 0 next door, you're going to draw a box around the 0 and whatever the next non-0 is. So if this was a 0, I'd have to keep looking for numbers. But fortunately, it's a 0 and then a non-0, like a 1. Okay? So I have a 10 here in this box. Why did I do that? Check it out. This 2 is not big enough to subtract a 7. So I'm going to borrow a 1. I can't borrow a 1 from the 0, so I'm going to borrow 1 from this 10. So I'm going to take 1 away, making this 12. If I take 1 away from 10, I have a 9. Right? And then I can finish my problem. It's pretty straightforward. 12 minus 7 is 5. 9 minus 9 is nothing. So there were 52 more sandwiches served in January than there were in December. Okay? Hopefully you enjoy boxing these numbers. You'll find that it can clarify a lot. So by drawing a box around the 0 that you can't borrow from and its neighbor, right? Hopefully that neighbor is not another 0, or else you have to make your box bigger. Then you can borrow a 1, remove 1 from whatever's in the box, and then keep subtracting. Okay? Let's see what comes next. There were 6,742 bags of potato chips stored in the cafeteria. They served 781 of them at lunch and 89 more of them as snacks for the students in aftercare. How many bags of potato chips are left? Oh, so we have a total, 6,742. They served 781 at lunch. So there's your subtraction problem. You're going to use your standard algorithm to work this out. When you are done with this answer, whatever this answer is right here, rewrite it and subtract 89 from it, because they also served 89 after school. Okay, so there are 2 subtraction problems in this question. 6,742 minus 781, and then whatever this answer is, rewrite it and subtract 89. Okay? I am going to let you do that one on your own. At the baseball game last night, the home team was losing by 48 points at halftime, so fans started to leave. When the game started, there were this many. This many left at halftime. Then another amount left before the last quarter. How many people were actually there to watch the rest of the game? It looks like we have the same kind of problem, but with larger numbers. Now, I will say, you could do this a couple ways. 45,862 minus 17,946. Whatever this answer is, rewrite it, and then subtract 13,892. If you want to throw in a little addition, what you could do is combine these two numbers and then subtract it from there. That is a possibility. If you feel like you're a little bit more successful with addition problems, then you only have to subtract once. But that's going to be left up to you. You are going to have to do two things. Either add and then subtract, or subtract and then subtract again. Okay? Good luck with this problem. I know you're going to do amazing. If you have questions, make sure you ask a trusted friend or adult who can help you with math, okay? Teachers love to help. Check you later.